Hey Algebra students! So far in this unit, you've learned how to solve quadratics in many different ways. You learned how to solve by graphing, by factoring, and by square rooting. Today, you learn a strategy called completing the square, and that's how we're going to solve quadratics today. Now let's think about the previous lesson, where we used square roots to solve quadratics. In all three of these examples, you can see that we can square root both sides in order to solve what x equals. In the third example, first we would need to factor this trinomial. And once we have the factored form, then we're able to square root both sides since everything is a perfect square trinomial. But not all quadratic equations are perfect square trinomials. But we can only use the square rooting method if it is a perfect square trinomial. So, is there a way we can turn any quadratic equation into a perfect square trinomial? Why, yes, there is. And that's what you're going to learn to do today. To learn this strategy called completing the square, first you need to think about standard form of a quadratic equation, which is ax squared plus bx plus c. And now think about the relationship between the b and the c in any perfect square trinomial. I've gone ahead and drawn a diagram to kind of help visualize that perfect square trinomial. This box, this square, represents x squared. This long rectangle represents each of the x's. So I have 3x on the left of the box here and 3x's below the box. That represents all 6 x's that we need in this trinomial. And then as you can see, the c term right now is missing. So how many little squares of 1's do we need in order to make this into a perfect square? As you can see, that's laid out in the diagram. I would need 9 little squares to make this a perfect square. So the missing c term in number 1 is 9. Let's use the same strategy to figure out our missing c term in number 2. We have, again, x squared as this big square. Then we have 8 x's laid out as rectangles. 4 on the side this way, and 4 below x squared this way. So how many little 1's do I need in order to be able to complete my square? Well, since this is a 4 by 4, we would need 16 little squares. So 16 is the missing c term that completes our square. Can you guys see why this is called completing the square? We are literally filling in the space that completes the square diagram. So that's why the strategy is called completing the square. Let's try some more. Draw a diagram for numbers 3 and 4. Complete the square to figure out the new c value. So for number 3, the diagram has already been started. We have this big square representing x squared, and then we have this x and another x here. But I need a total of 10 x's. So I'm going to need to add more x's to the side and more x's on the bottom. Well, how many more x's do I need to the side? Well, if it's 10 x's, I'm probably going to need to lay it out like 5 on the side and 5 on the bottom. So let's make copies of this so I can complete my diagram. So now I have 3, 4, 5 x's out to the side. And then I'm going to create 4 more. So a total of 5 x's on the bottom of x squared. That's 3, 4, and 5. Cool. So now I have a total of 10 x's. How many of these little ones do I need to complete the square? Well, we know this is 5 by 5, so 5 times 5 equals 25. So that's how many little ones I need to complete number 3, or complete the square in number 3. For number 4, to start with my diagram, I need a box that says x squared. So here's my x squared box. Then I'm going to need 4 x's. So I'll probably need 2 to the side, just like this. And then 2 rectangles on the bottom to make a total of 4 x's. There we go. So how many little ones do I actually need in order to complete number 4? Since this is a, 2 by 2, we would need 4 to complete the square. So are you guys seeing the pattern with this? When we complete the square, the dimensions are always half of the middle number, since we need to split up the middle term into 2 different pieces when we draw our diagram. So the trick here is to take the middle term. In number 4, that's a 4. Divide that by 2, so you can find half of it. And then to find the area of the little square, you would need to square half of b that you found earlier. So that's how we're going to complete the square every single time for every single trinomial. Let's try some more, this time without diagrams. We know that to complete number 5, we would need to take this b term, find what half of this is, 2 divided by 2, which equals 1, and then I would need to square this, since 1 just gives me the side length of my square. So 1 times 1 is 1, so that's how I complete the square for number 5. For number 6, again, we take the b term, figure out what half of it is, in this case is -3, and then I square that number to figure out our new c term. So for number 6, it's plus 9. Number 12, or number 7, I need to find half of 12, which is 6, and then square that number. So 36 completes the square on number 7. Number 8, find half of -5, which is -5 halves. And students, work with fractions, because it'll actually save you some time when you get to other later problems. Then once you find half of the b term, you square it to find the c term. -5 times -5 is 25 for the numerator, and 2 squared is 4 for the denominator. So that's how we complete the square for all these 4 problems.